Okay guys, today we're going to draw a picture that represents osmosis. So the first thing I want you to do is find a sheet of paper. It doesn't have to be plain, it can be notebook paper, whatever you have. And I want you to fold it, landscape it first, so it's long ways like this and not portrait like this. So we're going to landscape it and we're going to fold it into thirds. And you can pause this video as you go so you can keep up with me. So we're folding our paper into thirds, and then we're opening it back up like this. Okay. In our middle section here, with any color you'd like, where I'm using color pencils. If you have pens or whatever, you do need to have some color here. So use different color pens, pencils, whatever. I'm just going to title it Osmosis. OSMOSIS with my horrible handwriting, which you will get used to. Put a little box around that, and there we go. I'm going to stick with my dark color pencil, and I'm going to draw 3 beakers in these little these thirds that I have made. So basically it's going to look like a little cup, like this. That's beaker 1, and my beakers look a little sad sometimes, but that's okay. These are just going to be there to represent water that we're going to hold in these beakers. Beaker 2. You need to do this because you're going to take a picture of it and send it to me, so make sure you get this done. And beaker 3. So as I scan across so you can see everything, I've got beaker 1, beaker 2, beaker 3. You may want to pause the video so you can get that much done. Okay, we're going to change colors, and you might want to find a blue or a shade of blue, and we're going to put some water in these beakers, and we're just going to make it look like wavy water here. I'm not going to really shade it in. In each of our beakers here. And what we're representing here is we're going to represent a cell that is placed in different solutions. Remember, osmosis is the diffusion of water through a membrane. So our membrane is going to be our cell membrane. In this case, it's going to be a red blood cell that we place in different solutions of water, and we'll represent this. So what we're going to do up top is we're going to basically place a key. So we're going to use our blue dot, make this little key up in the corner to represent our water. And change colors to whatever color you want to use here. I'm going to use I want to contrast it pretty well here. Red dot is going to represent salt. So we're going to show what happens when I put different cells in salt concentrations of varying levels. So I have blue dot water, red dot salt, and I have 3 beakers with some wavy lines in them, and that represents a water level. I'm going to start in the middle. Okay, so in the middle, I'm going to start with what I represent as normal concentration. So right up top above this beaker, I'm going to write the word normal. And write the word normal. Normal means that your cell is moving water at a normal rate, in and out at equal rates. So your cell, which I will draw as a green cell, is just going to be a regular looking blob here. Okay, this is your cell. We're not going to put a lot of stuff in it here. We're just going to represent it as the blob. So this is your cell. I'll just label it down below because I don't want it to look too messy. So that's your cell, just a regular old cell. And I'm going to put 3 salt dots on the inside because your cells do have a salty concentration. But I'm also just going to put 3 salt dots on the outside. I'm going to put 4 water molecules. Now there's more water molecules than I'm representing, but I'm just putting this here just for clarity's sake. There's 4 water molecules on the outside, and there's 4 water molecules on the inside. My point is, everything is even. So pause the video and get your dots made. Now that you've got your dots, you see that there's 4 water molecules on the outside, 4 water molecules on the inside. There's 3 salt molecules on the outside. There's 3 salt molecules on the inside. That is an equal concentration. That's normal. So normal means equal concentration. Just a reminder, this is all passive movement. This does not mean, passive means no energy. When you're moving, concentration. When you are moving, it's a big word there. Concentrate. Oh, God, I misspelled it. Concentrate. Get rid of that N. Concentration. Tray. Concent. There you go. Concentrate. Holy moly. Edit this part of the video. Equal. C-O-N. There we go. Equal concentration. Okay, so that doesn't mean molecules stop moving. It just means they move at equal rates. So this molecule will move in and this molecule will move out. If molecular movement stops, we're dead. So we don't want that to happen. So what we're going to do is we're going to draw arrows moving out and arrows moving in. I was trying to be cute with my arrows, but you get it. So there's an arrow moving out, and there's also going to be an arrow moving in, which means molecules are going to be moving out and in at equal rates. Out and in at equal rates, all right? So it could be salt, it could be water, whatever. The big point here is at the bottom, I'm going to draw a star, and I'm going to put cell remains same size, remains same. Cell doesn't change at all. Okay, that's your big point. And that's what we want in our cells. Sorry about the mess right here. But this is normal. Okay, this is also known as a vocab word you had, isotonic. When molecules move in and out of the cell at equal rates, the cell remains the same, and that is known as an isotonic concentration. Pause the video, get this down, then we're going to move to the left into the first panel. All right, now that you've got the middle panel complete, now we're going to look at what happens when there is a salty concentration around the cell. So we're going to pick up the cell color that you had over here, which for me was green. And this time our cell is going to be all shriveled up, so it's going to look much smaller. Like that. Kind of like a deflated balloon. And on the outside of your cell, you're going to put, let's put about 10 salt molecules. This is like pouring salt on a slug. If you've ever poured, oh gosh, my lights went out. Hold on. If you've ever poured salt on a slug, you know that it gets kind of, it dehydrates. So that's what happens when you do that. We're still going to put some water molecules out here because there's always going to be water molecules in a water solution. So it doesn't really matter how many. Just look at the salt here. So there's more salt on the outside, and then there's going to be less salt on the inside. Put some water inside here. water will move from an area of water will move from an area of high water concentration to low water concentration. There's more water in here than there is out here cellularly. So what water will do, and because of the salts out here, I want you to remember two words: salt sucks. So salt's going to suck the water out of this cell into its surroundings. So the water, because of the salt in the surroundings, will move out of the cell into the surroundings. What this cell is trying to do is maintain an equilibrium. And it's not going to happen. The cell's going to die. The cell's going to shrivel because there's too much salt out here. So the dilution process, even though it's trying to dilute, is not going to work. So this cell is going to shrink. Cell shrinks. This is important to know what happens. This is called hypertonic because there's more, hyper means above, there's more salt out here than in here, so water moves out. So this is hypertonic. So we end up with a shriveled up cell as a result of that. This is not normal. If you're dehydrated, this is what's happening, because in your cell surroundings, you have more saltiness in those cell surroundings than you do in your cells. When you're hydrated, your cells are nice and full, and that's what we want. So the cell shrinks. This is hypertonic, and always remember, and I'll write this at the top here under osmosis, that salt sucks. So wherever you have the highest salt concentration is wherever you're going to see the movement of the water. Salt sucks. In the middle, it didn't matter because you were looking at the equal movement of water. But in the left and the right, it does matter because wherever you have the highest salt is where the water moves. Water moves towards salt. All right, and the last one, to get this one done, what we're going to do is we're going to make our cell kind of look like a bubble gum wrapper almost, because this cell's going to explode. So it kind of looks like this is the explosion that happens at both ends. All right, so that's our cell. It was getting full, and it's like a balloon that gets too full and it explodes because we have a lot of salt in here, and salt sucks. So which way does the water move? Into the cell. And we have a little bit of salt out here, lots of water out here, a little bit of salt, a little bit of water in here, a whole lot of salt. Water's going to move from an area of high to low concentration. So water's going to move. Oh, I didn't put my water dots, did I? Let's put some water dots. Lots of water out here, a little bit of baby water in here. So water's going to try to move where the salt is, the most salt. The problem is the cell doesn't do a great job with a huge influx of water, just like a balloon doesn't do a great job with a huge influx or intake of air. So the cell explodes. This is all osmosis. Cell explodes. You put a saltwater fish in a freshwater aquarium, it's not going to survive because the cells are going to take, oh, that's supposed to be an S. The cells are going to take on water and they're going to explode. So this cell explodes, and that's known as hypotonic. Why? Because salt sucks. Where's your salt? Inside the cell. Where does the water go? Inside the cell. Hypotonic. The word tonic is tonicity. So that just means osmotic pressure. Where's all this osmotic pressure going? So when we have, just a quick review, when we have more salt outside, that's the red dots, more salt outside than inside, water leaves the cell. Because salt sucks the water out, the cell shrinks. When we have the exact same amount of salt on both sides, it's equal, so water moves in and out, the cell stays the same. When we have more salt inside the cell than out, water rushes in and the cell can't take on but so much water, and the cell explodes. This is all osmosis. It is a passive form of transport of water of water through a cell membrane. Osmosis only deals with water. We have not moved salt at all. We are only moving, let's write that up here so we don't forget. Osmosis equals water. Can y'all see me? Yeah. Water moving through a membrane. Water only, and it's not just moving, it's diffusing, so it's going from an area of high to low concentration. So what you're going to do is you're going to snap a pic of this. When you're finished with it, it is a grade. You're going to upload it into the assignment category where this video is located, and you're going to send it to me so that I can get you a little check mark for this assignment. Hope you have a great day, and we'll see you soon.